surface energy, and surface tension, surface energy and surface tension. Surface energy. In last lecture we have studied that is the potential energy. That means to increase the surface area, we have to do some work against intermolecular forces. That work done is stored in that liquid in the form of potential energy. And we consider here first surface energy. Simple definition of this surface energy, that is potential energy per unit area. Potential energy per unit area is called as surface energy. And next definition, surface tension. Surface tension, it is the force per unit length acting right angles to an imaginary line drawn in the free surface of liquid. Suppose this is the free surface of liquid, and if we draw the imaginary line, and suppose these all are the forces, then force per unit length, suppose F is the force and L is the length, then force per unit length acting right angles to an imaginary line drawn to the free surface of liquid is called as surface tension. Now we have to obtain here that is a relation between these two. Before that, T is equal to F upon L. Therefore, unit of the surface tension we consider that is Newton per meter or dynes per centimeter. That means if L is equal to 1, then T is equal to F. And dimensions of T we can write here, that is dimensions of force M1, L1, T minus 2, and dimensions of L, that is L1. And if we combine all these, then we get here that is M1, L0, T minus 2. These are the dimensions of surface tension. Now we have to see, or we have to obtain relation between these two, that is relation between surface tension and surface energy. I will write here, relation between surface energy and surface tension, or surface tension and surface energy. For that, suppose we consider this is the rectangular frame. Suppose this is the rectangular frame. That means we consider here that is a P, Q, R, S. This is the rectangular frame, and on this rectangular frame, suppose we consider QR, this wire slides. Okay. Now, if we dip this rectangular frame into the soap solution or any solution, then film formation is there. That means here PQRS, this film is formed. Now, suppose we consider we apply the force to this QR in this direction, and suppose new position of QR is like this, Q dash R dash. That means there is increase in surface area of this film. Initial area is PQRS. This is the area of the film, and we apply the force in this direction. Then this wire comes, QR wire comes at point Q dash R dash. That means there is a displacement of X. X is the displacement of this wire. Now here the force, T is equal to F upon L. Therefore F is equal to, I will write T into L, where L is length of this QR wire. L is the length of the QR wire. That means I get here F is equal to TL, or instead of, I will write here 2TL. That means this film have two surfaces. That means this surface, upward surface and downward surface. It have two surfaces. Therefore, I will write here F is equal to 2TL. Suppose I will write here F is equal to 2TL. Suppose this is equation 1. And here factor 2 is due to the soap film have two surfaces, both contact to the wire. Now PQ, here we consider this wire is pulled in this direction. Therefore, work done is equal to, I will write here W be the work done is equal to, I will write force into displacement, and therefore I will write W is equal to, force is this much, 2TL into, I will write here X. Suppose this is equation number 2. This is the work done. Now here additional surface areas here. Suppose PQR is, this is the original film, and due to the force, film is PQ dash, R dash, S dash, and additional surface area we consider here. Here is the length. Additional surface area means QQ dash R dash R into 2, that means upward and downward. Therefore, additional surface area I will write A is equal to L into X, and I will write here 2LX. This is the additional surface area created due to the force. And if we consider, we divide equation 2 by equation 3, then we get here W upon A is equal to 2TLX upon 2LX, and here these two cancels, and therefore we get here W upon A is equal to T. Suppose this equation number 4, this work done is converted into P per unit surface area. Work done per unit surface area or potential energy per unit surface area is called as surface tension, or we write here W is equal to T into A. Suppose the equation number 5, and from equation 4, T equal to W upon A, therefore new unit is, we write here joule per meter square or ergs per cm square. This is the new unit of surface tension, and we have studied relation between that is surface energy and surface tension, all about this. I hope you all understand this. Now we will consider next article. Angle of contact. Angle of contact. What is meant by angle of contact? See here. Suppose we consider a free surface of liquid is contact with solid. Then we consider, suppose suppose we consider this is the container. In this container there is a liquid, and suppose we consider a capillary, or we consider any tube is here, and suppose here in this tube there is also liquid. Suppose this is the liquid, and we consider here here is also liquid, and we consider another one same type. Suppose this is the liquid in which suppose same tube is placed. Both diagrams are identical, you understand? Okay. And suppose we consider liquid is here. Now if you observe here we get the concave surface, and here we get the convex surface. Concave surface and convex surface. Now here suppose we draw a tangent. We draw a tangent to the liquid surface at the point of contact. Suppose this is the tangent. Here we draw the tangent. Now here we will draw the tangent like this. Okay. Now here we consider, suppose this angle theta. Here we consider, suppose this angle is theta, and this angle theta is the angle of contact. That means how we will define this angle of contact? See here, angle of contact is angle between solid surface, and tangent drawn to the liquid surface at the point of contact, and measured in the direction of liquid. See here, angle between solid surface and tangent drawn to the liquid surface at the point of contact and measured in the direction of liquid. This angle is called as angle of contact. Here you see, here concave surface, here angle of contact is less than 90, acute angle. And here for convex surface, this angle of contact is greater than 90. We call it as a obtuse angle. Both angles are possible. Sometimes theta is equal to 0 is also possible. And also in some types of liquids, we can't get angle of contact. We study one by one. Here you see, this angle of contact is acute, this angle of contact is obtuse, and for some liquids theta is equal to also 0. We see one by one. I hope you all understand this angle of contact. Again I will explain. That is, angle of contact is angle between solid surface and a tangent drawn to the liquid surface at the point of contact and measured in the direction of liquid. Angle of contact is angle between solid surface and a tangent drawn to the liquid surface at the point of contact and measured in the direction of liquid. This is all about angle of contact. In next article, we will study, that is, characteristics of angle of contact, shape of the liquid drop. I hope you all understand this. Thank you.